Okay, moving on to our literal equation solving. We still have to justify each step, but my main focus is going to be on isolating the variable they talk to us about, or that they tell us to. Number 4, I'm choosing at this point to move to line paper. My paper was a mess. I have to solve this for y. Put it away, Tony. I have to solve this for y. Is that your, yeah, go ahead and take one and then put it away. I realize what you have. Not a bag of chips, right, kid? It is a bag of chips? No, right. I knew what it was. All right, so if I've got to solve this for y, that means I've got to undo everything going on around it and leave it as a y equals. If you can think back to Algebra 1, this was like y equals mx plus b. I'm getting it into slope-intercept form, really is what this problem is about. What would be the first step? Any suggestions for the first step to get this stuff all by itself? I'm going to take 9x's away from both sides. And the best thing I can do right now then is just write this as 2y equals. I'm going to put negative 9x plus 5, only because this is a typical setup, y equals mx plus b, that linear idea, and I recognize that. What property justifies what I did? Subtraction property of equality, because we still have to keep justifying it. As long as we subtract on both sides of the equal sign, we're all set. And I'm still searching to get y alone. What would I do next? I'm going to divide everything by 2. Now, when I say I'm going to divide everything by 2, check out what's happening here. You guys are going to definitely want to use these as models. Everything gets divided by 2. Both terms on the right-hand side as well as what's going on the left-hand side. Now, in some instances, you'll see, and I bet you in your textbook it does this, where it puts a line under everything and it's just a single 2. But then you'll watch in the next step, it breaks it apart and says put that divide by 2 under each piece. So I'm going right into divide by 2 here and all the pieces on the other side. So then I'm getting down to y equals, and I'm going to just write these as fractions. Negative 9/2 x plus 5/2. No problem. Leave them as fractions. There's no reason to put them as decimals. What property justified what I just did? So I wouldn't be using any substitution to check the answer because I have y as a whole entire quantity, not a value to plug in. Now, number 5 looks a little bit more complicated because of the fractions, but I like that this is an example I can do in front of you, so you have a fraction problem to refer back to. 1/15 s minus 2/3 t equals negative 2, and I have to get s all by itself. So what would I do first to get s all by itself on the left-hand side there? What can come away from the 1/15 s? Louder. Add 2/3, take the t with it too. Get it out of there. When I go to get it out of here, it's not like negative 2, so I'm not going to be able to put those together. That was addition property. I'm just going to drop that over there. That's addition property. I think this property stuff is going to get in your way. 1/15 s equals 2/3 of t minus 2. So these aren't like, so I just have to write them as the expression 2/3 t minus 2. Now, my very next move is get rid of that 1/15 times s. I don't know if it's come up. I know I've talked about this in Algebra 2, but I'm not sure this has come up in front of you guys this year in geometry. If you want to get rid of a fraction, you multiply by its reciprocal. 1/15, if I flip 1/15 over, its reciprocal is 15 over 1, or just 15. So I'm going to come on this side, and I'm going to multiply this side by 15 as well. 15 times 1 is 15. 1 times 15, these guys would cancel out. So s would be equal to, and watch what I'm going to do right now because I'm bringing in another property. In order to multiply everything over there by 15, I'm going to have to distribute. You all right? Okay. This was, what did I do here? So this is going to be multiplication property of equality. Multiplication property of equality. So what's next? Getting back on track here. I said it a moment ago. What do I have to do with this 15? Okay, so S is going to be equal to, geez, we had to solve for S. Somebody might say that's all right, but I'd like to take it to the next step. 15 times 2 is going to give me 30 over 3t. 15 times 2, 1 times 3, 30 over 3. Minus 15 times, I've already got the negative there, that's going to be minus 30. I feel like this could be simplified. What's 30 divided by 3? Yeah, so I could just rewrite this as 10t minus 30. Actually, that's way prettier than where I stopped here. Way prettier than where I stopped there. And right here, I would justify this with distributive property. And I don't know if I would even justify this next step by saying anything other than I simplified, because I took my 30 over 3 to 10. What questions do you have right now? What questions do you have right now? So I'm going to go on to 6. We've got a formula in the context of a problem, and this is very typical of what we'll see in geometry class. The formula for the surface area of a cone is capital S equals pi r squared. Oy, oy, oy. They want us to solve this formula for S. They want us to solve this formula for S. Little s, that is, and justify every step in solving the formula for little s. I'm leaving this here. I'm going to move over back to my paper because I feel like I've got enough room down here to do number 6. So I'm going to start over here with writing down the formula. Capital S. Join me with copying it. Little s. It's kind of buried, so it's going to be kind of a long process, I think. Multiple steps to get s all by itself. Look at the formula in the problem. It's pi r little s capital S. The formula is on your page. Solve the formula for little s. Once we actually solve it for little s, we got to go and use it and do something different. So lots of layers to this problem. So little s is buried in this second term. So the first thing that I'm going to do is I'm going to take away this pi times r times squared. Pi r squared. So that was a little subtraction property. Oh, yeah, it does say justify each step. So subtraction property of equality. S, capital S, minus pi r squared equals, my equal sign moved, pi r little s. Still trying to get little s alone. You know what I like about this problem too is the variable I'm trying to solve for is actually on the right, it's on the right-hand side of the equation. And just because it's on the right-hand side, there's no problem. Like, you don't have to have your variable on the left or anything. There's no rule. It just has to be alone. So I took away this piece to get it moved over to the left side. I subtracted. And that, yeah, we're getting there, Dominique. Hold on. So I took away this piece to leave this chunk by itself on the right-hand side. And then I put dots in there to show that what's going on the right-hand side is multiplication, pi times r times s. How do I undo multiplication? Division. Now you can go ahead and you can divide everything all at the same time. Watch, pi r. Get it all out of there. Divide by pi r. Divide by pi r. So both pieces on the left got divided by pi r, and over here on the right got divided by pi r. Cancel, cancel. Bye-bye. That's our, yep, good. Okay, division prop. Now, you see anything else? So over here on the right-hand side, that whole thing helped me to get to, here's s, right? The only thing that's left, my little s. Lord help us here. We got this. This thing, I can't divide anything else out. I can't you know, simplify it. I can't cross them out. So this is going to come down as, I don't like how the words are here. Hold on, you guys. Let me just bring it down a little bit further so I can write around here. So now I'm going to have S over pi times R. But as far as I can tell, those can divide out. And what about R squared over R? One of them is going to divide out. This R could take away that square and leave me with just one of them. Because R squared means, maybe I should write this differently. R squared, doesn't R squared mean R times R? So if I do R times R, you see how there's just an R left? I know, right? No more 8th grade or Algebra 1 solving. We're taking this to a whole new level. Well, you can do it. I have all the faith in the world. Just because it's too much doesn't mean we can't handle it. It's just going to take more work. Ask me a question. Where did I lose you? Okay, well then let me start this problem all over again. No, I don't know. I'm not